Hi, my name is John Mazurik, and I work for the U.S. Geological Survey in Asheville, North Carolina. We put this video together for the HDAC video series on what hydrologic technicians do to show you a routine stream gauge inspection. Stream gauge inspections are a major part of the work hydrologic technicians do in the field within the U.S. Geological Survey.
This video will look at a routine USGS stream gauge inspection at a few stream gauges located in western North Carolina and maintained by the Asheville Field Office. When a hydrologic technician first arrives at a stream gauge, they read the primary reference gauge. This reading is considered the correct reading during a site visit. At this site, the primary reference gauge is a set of staff plates. This plate appears to read 1.62 plus or minus 0.01 feet. Another example of a primary reference gauge is a wire weight. A brass weight is lowered from a spool and the reading on the dial is read when the bottom of the weight hits the water surface. After the primary reference gauge is read, the electronic data logger is then checked to make sure the readings agree within 2/100ths of a foot. In this case, the staff plate and data logger readings agree. Readings are then recorded in electronic field notes. Some common components of a USGS stream gauge are a data logger, a GOES satellite transmitter, and a stage sensor. At this site, a non-submersible pressure transducer is used as the stage sensor. The sensor is located on the inside of the gauge and reads the back pressure of the water through thick-walled tubing that connects the pressure sensor to the river. The tubing is run through a conduit to a position below the water surface where it is mounted in a fixed position. Compressed air is blown through the tubing to regularly purge the line and keep the end of the tubing clear of debris and vegetation. The end of the pipe is also serviced regularly by cleaning debris and algae from the cap. After maintenance, the data logger is read again to make sure the pressure sensor readings did not change after the cleaning. Next, we are going to look at another type of stream gauge that is far less common nowadays, a stilling well. These large wells are connected to the river by a series of galvanized pipes, and a float and counterweight are used to record the water level in the well. The black plastic float is connected to a steel tape that runs around a metal wheel on the upper shelf with a sensor that records the stage in the well based on how much the wheel spins. This is called a shaft encoder. A secondary reference gauge, in this case an electric tape, can be used as another check of the water level in the stilling well. When the weight hits the water, an electric circuit is completed and the dial on the voltmeter registers a reading. The values recorded on the electronic data logger are compared to the values of the reference gauges. Here, you can see the shaft encoder where the steel tape passes around the wheel. As the wheel on the encoder spins, the stage reading changes. Max-min clips attached to the steel tape beneath the instrument shelf mark the maximum and minimum travel of the steel tape between inspections. During site visits, the wheel on the shaft encoder is spun until the clip meets the bottom of the shelf. The data logger is simultaneously read, and max and minimum values between visits are recorded. Max-min clips are one method to validate peaks in the stream flow record and ensure the accuracy of peak data recorded at stream gauges. At the first site we looked at, there was no stilling well, so we have to use another method to validate peaks. Crest stage gauges are vertical pipes with specialized tops and bottom caps used to measure peak stages at USGS stream gauges. The wooden stick inside the pipe is removed during site inspections, and the distance from the top of the stick to the cork line is measured and documented. Crest stage gauge pipe elevations are surveyed routinely, so the elevation of the top of the pipe minus the distance to the cork line equals the elevation or gauge height of the largest peak since the last inspection. Granulated cork, used to mark the peaks on the wooden sticks, is replaced in the bottom cap of the pipe to ensure that future peaks are recorded by the crest stage gauge. Any cork marks are removed from the stick, and the crest stage gauge is closed back up and ready for the next peak. Since the electronic data is based on the readings from the primary reference gauges, we need to ensure that the reference gauge elevations are accurate and not changing through time. Stream gauge surveys, or levels, are performed at recurring intervals at all USGS stream gauges. During stream gauge surveys, level rods are held on multiple reference marks. Additionally, the reference gauges are surveyed and, if found to be reading off by 15 thousandths of a foot or more, the reference gauges are adjusted to read the correct gauge height. A wire weight is surveyed by comparing the elevation of the bottom of the weight with the reading on the wire weight dial. During site visits, the condition of the control is routinely documented. The control is the part of the river holding the water back in the pool that the stage sensor and reference gauges are located in. In this instance, the control is a section control that consists of cobbles and boulders and is located 80 feet downstream of the gauge. Any debris deposition, aquatic vegetation growth, or any obvious changes to the riverbed are documented because these changes can have a significant impact on the stage-discharge relationship at the site. Before leaving the site, data from the data logger is manually downloaded. At most sites, the data has already been transmitted to the database and web via satellite. However, the electronic data log is stored as a backup and used to fill any gaps in the record. The site power system is routinely serviced during site inspections. Gauge batteries are tested for charge and load capacity and swapped with fully charged batteries when necessary. Many USGS stream gauges are powered by solar panels. These panels need to be clean and facing the correct direction to provide an adequate amount of solar power to continuously power a stream gauge. For non-submersible pressure transducers, desiccant must be maintained in the air intake system in order to keep the humidity inside the pressure sensor low. Thank you for watching our routine stream gauging inspection video. I hope you enjoyed this glimpse into some common field tasks of a USGS hydrologic technician.